Good afternoon, everyone. We're going to be starting the conference now, and I'm going to turn it over to Jack Bukowski. Jack is the chair of the Water Planning Council for Connecticut. Thank you, Jack, for joining us.
Thank you very much, Denise. Good afternoon, everyone, and welcome to our ongoing series celebrating the National Wetlands Month, the 50th anniversary of the Connecticut Inland Wetlands and Watercourses Act. And I'm happy to be here on behalf of the Council and its relationship to what we're doing with the Water Planning Council when it comes to this subject area. This afternoon, we're going to have a session on wetlands and climate change, mitigation and resiliency, and it's hosted by the Water Planning Council Implementation Outreach and Education Subgroup, and I thank them for all their work on this. And I should note at this point that one of the things we're going to be talking about today is drought and the flooding, but we have a very active interagency work group on drought headed up by Undersecretary of the Office of Policy Management, Martin Heft. And we know that Connecticut is experiencing changing precipitation patterns that are alternating between intense rainfall and periods of extended drought. And we can't seem to get it together in one direction. And this seminar this afternoon will focus on the ecosystem services provided by inland wetlands related to flooding and drought and impacts to wetlands for climate change. So I'm very happy to kick this off this afternoon. And I'm going to introduce Michael Dietz, who is very active with us on the Water Planning Council, and he serves on the Water Planning Council Implementation Group, and we're happy to have him. And he is an extension educator at the University of Connecticut and joint faculty member of the Department of Natural Resources and Environment. He has a background in water resources with a focus on green stormwater and techniques, and he took over as director of the Institute in January 2018. So he's going to be moderating the panel. Great expertise in the area, and I welcome Michael Dietz.
All right, thank you very much, Jack. So welcome, everybody. We appreciate you taking some time with us on this beautiful spring day. It seems like spring has finally arrived here in Connecticut, so it's tough to get inside on a day like this, I know. So just very briefly, we have our three panelists who will be speaking today, and if everybody again could just mute, please, if you're not speaking, we'd appreciate that. Or Denise, you can mute them too. There we go. So very briefly, I will introduce our speakers. They have a few slides just to talk about some of the areas that they have specialty research on, or specialty expertise on. And we will have a couple of questions that we will then pose to each of our panelists, and we will then open it up to questions from the audience as well. So if you do have questions throughout the presentations, please feel free to drop those in the chat, and Denise will be collecting those so we can ask them at the end of our panelists. So again, just as Jack said, we know right now that the changing climate is more than about just the increases in temperature that we're seeing. There have been major impacts to the hydrologic cycle in this state, in all over New England really, but specifically here in Connecticut, with more intense precipitation events happening and also more extended periods of drought. So this is a very challenging situation for any ecosystem, and that's what we'll be focusing on for today. So with that, I will introduce our panelists. So first, we have Kip Kolsinskas, who is a consulting conservation scientist. Many of you may know Kip from his former life, where he was the Natural Resources Conservation Service state soil scientist for Connecticut and Rhode Island, where he worked extensively with farmers, educators, government, and nonprofits to help them protect farmland and wetlands and use soils information to make better informed land use decisions. KIP's current projects include assisting agencies, NGOs, and private individuals with farmland protection, land access, and affordability for new and beginning farmers, farmland restoration, and climate change adaptation strategies. He's contributed to numerous publications and initiatives, including Conservation Options for Connecticut Farmland, Planning for Agriculture, a guide for Connecticut municipalities, and the award-winning training videos for Connecticut DEEP's Municipal Inland Wetlands Agency Training Program. Second, we have Gardner Bent, who is a hydrologist with the United States Geological Survey, New England Water Science Center, based in Massachusetts. He's been with USGS since 1989 and is currently the surface water specialist for the center. During his career, he's worked on studies involving statewide equations for estimating stream flow statistics and bankful channel geometry, sediment transport assessments, flood-related studies, and watershed assessments. And lastly, we have Dr. Beth Lawrence, who is a wetland ecologist here at the University of Connecticut in the Department of Natural Resources and the Environment. Beth formerly was an assistant professor in the department, but just this month was formally promoted to associate professor with tenure. So congratulations to Beth. She is also split with the Center for Environmental Sciences and Engineering here at UConn. She teaches 2 wetland science courses and mentors undergrad and graduate students. She recently was selected for the Society of Wetland Scientists 2022 Outstanding Educator Award. And Beth's research focuses on how anthropogenic change agents like road salt, plant invasion, sea level rise, or ecological restoration alter wetland community composition and ecosystem function with an emphasis on biogeochemistry. So we welcome all of our panelists today, and we will start out with Kip. I'm just going to switch over the share here. Okay, does that look okay? Do you see that full screen?
Great. So again, congratulations to all that have helped enact and implement the Inland Wetlands and Watercourses Act. I know that it's protected critical natural resources and prevented the loss of life and property. Again, climate change is not something that's coming. Climate change is here with impacts all around the world. And those that have continued to fill and drain wetlands and build on floodplains are certainly feeling the impact. Again, I appreciate Mike for the introduction and a little bit about the projections that we're experiencing as well as current conditions. So next slide. I want to just take a little bit of a look at how wetlands are being impacted, ecosystem services, and starting out with did you hear me, Mike? Next slide, please. Okay, great. Yeah. Just a little review of some of the features of soils and soil landscapes. So we're all kind of on the same page of what makes wetlands wet and why. And then as Mike talked about the changes to the hydrologic system and also changes to the temperature regime as how those might impact wetlands. So I just want to highlight a few things. I'll let you read through, but I'm going to highlight a few things on each one of these slides. So one, as you might expect, forms of wetness for inland wetlands and watercourses, flooding and ponding. Those are typically things that you would expect make soils wet. And then probably one of the most important things is saturation. So for how long is the soil saturated at or near the surface during the growing season and for what part of the year? And there's a couple of terms you may or may not be familiar with that you can use at the next party you go to is endo and episaturation. So what that actually means is are all the soil layers or horizons saturated all the way to the surface or near the surface, or is it saturated in the upper part and maybe unsaturated in the lower part? And on the right, you'll see kind of a classic cross-section of a Connecticut landform of dense glacial till, or what people would call hardpan. And you can see at the top there, you've got that very firm, dense, unsaturated layer is perching water up on top of there and creating a little wetland. And then you can also have, it's trying to get down to that wetland at the bottom of the slope. So you can have seepage and groundwater discharge and even wetlands on that slope. And then of course, that it's providing saturation and base flow to the wetlands and watercourses down there at the base. And really the landscape position and the inherent soil properties and such as parent material and the depth to that water in the soil profile and even above the surface and the duration of wetlands are really what's important to whether or not something is going to be wetlands and how much impact there may be from climate change. Next slide, please. So I'm going to focus on wetland soils, very poorly drained, floodplain, alluvial soils. Obviously, there's Watercourses are part of the definition as well. Some of them are the same. They're poorly drained, very poorly drained floodplain soils, but there are also some other features as well to watercourses. And I just want to highlight a few items here as well. So the extent in the landscape and position and the size of the watershed is important for the ecosystem services. So is it a small isolated wetland, or is it a big, bold and beautiful wetland with a large watershed? I think that there is greater recognition now that soils store carbon and sequester carbon from the atmosphere, and that wetlands, particularly wetlands in our part of the world in more of a northern hemisphere, cooler climate, are really, really good at sequestering and storing carbon. So wanted to call that out. And then, particularly as it relates to our water resource issues and ecosystem functions, the fact that these landscape positions store surface and groundwater and allow that slow release of surface and groundwater. So think about how that might be impacted by the changing hydrologic regimes. And then the other thing, which again, I'm sure Beth's going to talk about in detail, is some of those other services, such as providing critical habitat and biodiversity. Next slide, please. Next slide, Mike. Okay, ecosystem services of floodplains and alluvial soil. So Denise asked me to have a special shout out to the wisdom of those folks in including the protection of floodplains and soils of any drainage class, from excessively drained to very poorly drained. And so those soils exist along rivers, streams, and intermittent watercourses, and they really are critical parts of the hydrologic system and ecosystem. So if we had not included those, we definitely would be missing out on a really critical part and of those ecosystems and those ecosystem functions and services they provide. So, and we must continue to be diligent. We all know that people like to live near water, and there's a lot of pressure, but that's at your peril. And you can just see by what's in the news, levees are only having a minimal effect in some areas. So you can't count on a levee during a changing climate to keep you safe and sound. So let's go through a few of these specific things here. Again, we know floodplains, alluvial soils, they store floodwaters from annual to rare flood events, and then slowly release that floodwater downstream. They're able to deposit and store sediments, nutrients, organic matter. You see off to the right with this soil profile of an alluvial soil, that's an old surface layer, that dark area that you see. So it's actually storing organic matter, organic carbon all throughout the soil profile of that floodplain soil. And it can both recharge and discharge groundwater on the landscape. It's also an important agricultural resource. So when we think about it, the whole goal is really sustainability. So food security and changing the food system are a really important part of sustainability and climate resiliency. Again, thinking about the effects right now of wars and pandemics. And it's actually getting harder for farmers to farm on floodplains due to climate change. So we also need to make sure we're protecting upland soils as well as floodplain soils for agriculture. And then this last one I really want to highlight, and I'm sure Mike would could probably do a whole presentation on this, of the intersection of our uplands to floodplains are critical to recharge and maintaining base flows. And we really have not done a very good job of paying attention to what land uses are at that critical juncture of uplands and wetlands and floodplains. So that's something that deserves more attention. So let's go to the next slide. So here we are in the impacts, thinking about the impacts. And actually, I'm still out there digging holes throughout the year, and I've observed changes to the wetlands and to upland areas and to soil carbon. Obviously, there's some research that's being done. I think we need more research. We need more data, but I'll just call out a few specific kinds of impacts and things to think about here. So again, I would say, with these longer growing seasons, higher temps, less snowpack, frozen ground, more evapotranspiration, some wetlands are going to be drier for a portion of a year in some years. So think about last year, we had kind of a dry winter and a dry spring, and then a really wet summer. So think about if you're a critter or a plant, of how that might impact you. So I think we're going to have more carbon storage in some wetland areas and loss in others. And you may say, well, Kip, how is that possible if it's wetter? So to me, some of our wetlands, poorly drained wetlands, higher elevations that typically are cooler with a shorter growing season, now with a longer growing season, warmer daytime, nighttime temperatures, those stretches of over 90 degrees with warm nights, that organic matter just gets eaten up by microbes. So you can certainly see losses in some areas. So again, you're going to see increased rainfall in events. You're going to see more ponding, more frequent flooding, higher flood levels on our floodplains, changes to the seasonal flooding regime. That's been one of the challenges for farmers on floodplains. It used to be after the spring freshet from snowmelt, you could safely plant, or maybe you might have to worry about a hurricane event in the fall, but you can have flooding on any time of the year now on a number of our floodplains. And that's very, very challenging. I think you're going to see an increase in poorly drained soils overall, because we're going to be wetter, changes to stream dynamics, increase in areas of alluvial soils along some of our smaller streams. And then this last one, again, increased impacts in wetlands with impervious surfaces. So the more runoff that you're going to have, the more areas when you have manipulated hydrology from human influence, you're going to see big changes in those wetland systems. And again, we haven't done a very good job. We've done a good job of, I think, of protecting the regulated area, but not of the hydrology of some of our wetland systems, the impacts of nutrients, pollutants, changes in when water is there and how much water is there. And then we need to do a better job of, as relates to reducing impervious surfaces, sprawl development, and impervious surfaces are killers. Next, final slide, conclusion. Protecting and restoring wetlands and watercourses, or what we can call green infrastructure, are really cost-effective mitigation, adaptation, and resiliency for climate change. So, and addressing climate change requires us to take bold action now. So let's think about those brave citizens, elected officials, and public servants who 50 some years ago took that visionary step to protect critical ecosystem functions. So we have some really good roadmaps of what to do and how to do it from the GC3 report and subgroup recommendations, the water plan. So let's build on that last 50 years of the Inland Wetlands and Watercourses Act. It's only become more important, and let's really up our game. And I look forward to working with all of you on this. Thank you very much.
Fantastic. Thank you very much, Kip. All right, I'm going to switch us over to Gardner. Okay. Is that okay? Can you see the full screen, Gardner?
Yeah, that's great. Thank you.
All right, you're up.
Good afternoon, everyone. I really appreciate the opportunity to talk with all of you. Kip's presentation was great. So I'm going to talk a little bit about the role of wetlands with floods, as well as droughts, and a little bit with water quality. So as all of you know, the picture on the left there is from over 40 years ago, or about 40 years ago, but the effect of wetlands in reducing peak flows and kind of spreading that peak over a longer period of time. So one of the missions of USGS is to provide peak flow equations that estimate what these flood flows are going to be at ungauged sites within a state or a region. So are wetlands important to this? And so in New England, wetlands are very important to peak flows. And what we found is with these peak flow equations, which use different basin characteristics such as drainage area or mean basin elevation, et cetera, to explain what that flow is in an ungauged site in these equations, wetlands is generally a part of the equations. And it's a negative explanatory variable in the sense of that the more wetlands in a basin, the lower that peak flow is going to be. It's going to reduce the peak. So Connecticut's peak flow equations, Liz Ahern updated last year in 2020. And so storage didn't end up, storage, which we use as wetlands plus water bodies, didn't end up in the equation, but it was the last thing that fell out during the regression analysis. So, but it's it was replaced with NRCS hydrologic soils C and D, which are low infiltration rate soils, and they're likely going to be somewhat related to wetlands. So, but are in other states within New England, do we find wetlands a part of these peak flow equations? So yes, in Maine, wetlands is a part of the peak flow equations. In Massachusetts, it's storage, wetlands and water bodies. New Hampshire wetlands, Rhode Island storage, and Vermont wetlands. So we can see here that as we move forward and climate change becomes a bigger part of things, that wetlands are really important in reducing peak flows. So the next, I'm going to dive in a little bit more. The next slide, please. And so I picked two sites within Connecticut. And the top, I'm on the top of the slide here. And the first one is Stony Brook, which is in north central Connecticut and drains to the Connecticut River. Then we got Hubbard River, which is kind of in northwestern Connecticut on the Mass-Connecticut state line. And so they have varying amounts of wetlands within their basin. So Stony Brook is about 28% wetlands, the land area, and Hubbard River is about 9%. So there's about 3 times as much wetlands within Stony Brook. And what I did is I took the peak flows all the way from the 50% annual exceedance probability, or AAP, up to the 0.2 AAP, which is, so 50% AAP is going to be a 2-year flood, and the 0.2% AAP is going to be a 500-year flood. So we're looking in between those. So to compare them, I normalize these peak flows, the at-site peak flows, by their drainage area. So we can clearly see that Stony Brook, which is in green on the top, is 3 times as much wetlands in the basin, and the peak flows are lower than at Hubbard River. They're about 20 miles apart, but we can see that wetlands plays a part, the importance of wetlands in reducing those peak flows. And we can see it, the lower flows, or the lower, I should say, the 50% AAP, or the 2-year flood event, versus the 50, that the reduction becomes less. So it's at 35% for, say, a 2-year flood, and at a 500-year flood, it's about it is about 10%. So why is that? Well, we believe that this is because at these 2-year events, there's more storage available in the wetlands to hold that rainfall event or precipitation event. And then when you get out to the 500-year flood, these wetlands become saturated, and anything that goes in is going to start coming off. So the benefit for these really large floods where everything is saturated becomes less, but it's really important for this. And this is where we're seeing with climate change, an increase in these floods that happen every 2 years, every year. Those are the ones we're seeing big changes in over time. And then just down below, we got, this is just Maine, and it shows on the left, it's the basins are 5% wetland. On the right graph, we're on the bottom. So I reduced the graph on the right to be equal to the scale on the left. But you can clearly see that if there's less wetlands, the peak flows are higher for the 2 or 100-year recurrence interval, and the more wetlands, those peak flows are really reduced. So next slide, please. So I'm going to quickly talk about droughts. And so with climate change, we're going to have an increased occurrence of drought, which is going to affect the critical processes that sustain the biodiversity of these wetlands. And one of the other missions of USGS is to provide low flow equations for ungauged sites within a state or a region. And one thing that's kind of interesting here is that we've generally found at the low flows, I'm talking like the 90, the really lower flows, that wetlands, the area percentage is negatively related to stream flow, which, and at those low flows, we're mainly looking at base flow or groundwater discharge to the streams. And well, that's kind of, you think about it, well, it doesn't really make sense, but in the sense of it, that the wetlands do store the water and it's discharging, but at these really low flows, when it's been dry for a while, there's a lot of ET going on in those wetlands. And so they're contributing less to the stream flow in those particular areas. But with more frequent droughts, we're going to see lower groundwater levels, which could lead to drying of the wetlands, a reduction in ET because the wetlands are drying up, and then also a further reduction of low flows. So this is just an example, as Kip was talking about, more droughts. Well, hence the 2020 drought. And I picked a river over that I'm familiar with in southeastern Mass, Segregansett River, and it's got about 24% wetland, so not quite as much as Stony Brook. It's about 10 square miles, similar, but dry as a bone here in the late summer of 2020. And then in the lower right, we have a well, which is a few miles from that particular thing, but it's located right next to a fairly large wetlands complex. And so you can see that when the wetlands are filled, it's about 3 feet below, the water level is about 3 feet below land surface. And we can see the effect of all of a sudden the really dry stretch. And you can see these, that there's a quick reduction in the groundwater levels from these droughts. So next slide, please. And I'll wrap this up here. And just as everyone knows, wetlands are really good at removing pollutants from surface water. So we got on the left, it's a trap for sediments. And in the middle, we have nutrients, say, that are running off agricultural fields that become, the wetlands are good at removal of these nutrients. And then wetlands for chemical detoxification. For example, metals that may run off from a highway or something like that. So the last slide, the next slide, please, is just some links for people of work that the USGS does related to wetlands or wetlands and climate change. And I just threw those in there if people want to go in and explore. And that's everything I got. So thank you very much again for inviting me, and I appreciate it.
Fantastic. Thank you, Gardner. And I will be able to post the PDFs of these for folks. So Denise, I'm sure we can set that up somehow so those links will work for people afterwards if they're interested. Okay, let's get Beth up here. Okay, Beth, you ready?
Yes, great. Thanks so much, Mike and Denise, for inviting me. I'm really happy to be here today. So I just have a few slides kind of highlighting, wetland and wetland ecosystem services and focusing on diversity. So if you're like me, you like Lord of the Rings. And so when I talk about wetlands, I like to think about the 3 rings of power, right? So Kip talked to us about soils. So we need hydric soils. Gardner talked to us about hydrology. And the other third important component of wetlands is the vegetation, the hydrophytic vegetation. But, one ring to rule them all is really hydrology, right? And so Mitch and Gosling, who wrote the seminal book on wetlands, described hydrology as the single most important determinant of the establishment and maintenance of specific types of wetlands and wetland processes. So we know that climate change is changing the frequency of flooding and drought. And so that really dictates kind of the character, the nature of the wetlands on the landscape. And so, on the right-hand side of this figure, you can kind of see the feedback. So if we have the frequency of inundation, the depth and duration of the water table really determines, the physiochemical properties of the soil, how much oxygen and nutrients are available, which affect what kind of plants can grow in the structure of the habitat, which affects what kind of critters can live there, right? And so if any of you have experienced beaver dams on your property or natural areas where you live, you know that there are strong feedbacks between the biota, such as beavers, and the physical habitat. Next slide, please. So here in Connecticut, we have about 7% of the state is covered in wetlands. So over 200,000 acres, I forgot a zero there, of our state is covered with wetlands. And so Ralph Tyner kind of characterized what kind of wetlands those are in Connecticut. And so we primarily have palustrine wetlands. And so palustrine is the Latin term means marshy or wet ground. And these are freshwater inland wetlands, right? So the majority of our wetlands in Connecticut are freshwater inland wetlands. Just over 7% are coastal wetlands that fringe the Long Island Sound. Go ahead, advance, Michael. So of our palustrine wetlands, right, the majority of them, about half, are forested wetlands. And so we think about wetlands, oftentimes people just kind of say, oh, they're wetlands, but there's so many different kinds of wetlands out there. And here in Connecticut, we're lucky. We do have red maple swamps are our most common wetland in the state. Right now, if you go out any low dip in the road, driving on Connecticut roads, you will likely see a flush of skunk cabbage, one of my favorite harbingers of spring. We have black spruce bogs with all kinds of boreal relics. We have carnivorous plants. The hydrology really dictates this community. It is truly hydrologically isolated. So it's only precipitation fed. It's not fed by groundwater or surface water. And so it's very nutrient poor and supports a whole suite of super interesting species. In the lower right, we have Atlantic white cedar swamps here in Connecticut. Atlantic white cedar is an important timber species historically, and it's now a threatened community type. We only have about 10 different parcels of Atlantic white cedar swamp left in the state. And it's important habitat for critters such as bats. Bats use it as thermal refugia, which increasingly will be important as we see increasing temperatures. Advance, Mike. So about 50% of our palustrine wetlands are forested. About 15% are emergent wetlands, right? So emergent wetlands are not dominated by woody vegetation, but by herbaceous or graminoids or grass-like vegetation. And so we can see one of my students, Levon, here with his draining his boot in a beautiful sedge meadow here in the northeastern part of Connecticut. You're probably familiar with Phragmites australis, the common reed that is a non-native and sometimes considered a nuisance species, fringes many of our roadsides and some of our larger emergent marshes. And so just want to highlight that, our wetlands are not all the same, and they won't be affected by climate change equally, and they don't provide the same kinds of ecosystem services. So next slide, Mike. So Kip and Gardner have been talking about ecosystem services, so I won't spend much time here. But the Millennium Ecosystem Assessment coined this term, or really kind of promoted its usage back in 2005. But it's the benefits we get from ecosystems, right? And so Kip kind of highlighted some of the soil formation and nutrient cycling and carbon storage, the climate regulation services. And Gardner highlighted how flood regulation, wetlands serve a really critical role in our landscapes in mitigating floods and by storing the water and releasing it slowly. Another really important supporting service is habitat provision. Next slide, Mike. And so I'll talk about habitat provision on the next slide. I wanted to share with you just the importance of wetlands, right? So if we were to kind of put a dollar value on nature, and economists increasingly want to do this as a way to get people to care and conserve. Robert Costanza is a ecological economist who was one of the first to kind of put a dollar value on different ecosystems of our planet. And I just find it, kind of, I guess, not surprising, but interesting that freshwater wetlands and estuaries, including salt marshes, are our most valuable ecosystems on the planet. And so if going out and enjoying the beauty of our wetlands and appreciating the soil and hydrologic services doesn't do it for you, maybe the dollar values will. Next slide, Mike. And so, one thing that contributes to that really high value of wetlands globally and here in the US and in Connecticut is they support an incredible amount of diversity. Wetlands are considered to be biological super systems. They sustain over 40% of threatened and endangered species here in the US. There are many threatened and endangered species in Connecticut that are primarily use wetlands for habitat. I like this picture on the right of a wood duck standing on the back of a red-eared slider, just kind of highlighting all the different animals that utilize our wetland habitats. Wetlands are a critical habitat for waterfowl and migrating birds. They serve as nurseries for larval fish and mammals, amphibians, and reptiles all use, or many of them use wetlands for at least a portion of their life cycle. And so when we're thinking about climate change in Connecticut, I think it's really important to think about the diversity of different wetland ecosystem types that we have in the state, the kinds of ecosystem services that they provide, and how increased flooding and drought might alter the provisioning services. So I'd be happy to talk more about that. I believe Mike has some questions for us now.
Great. Thank you very much, Beth. Just stop sharing here. So since you're, we're fresh off your talk here, maybe, and actually really recently what you just spoke about, this idea of maintaining biodiversity in our wetland systems. So maybe could you just expand on that a little bit? Why that biodiversity is important in the face of changing climate for resiliency against climate change? You're still muted.
I'm muted. No, that's a great question, Mike. So, resilience is the capacity of natural systems to rebound after a disturbance. And so, it's critical that we conserve biodiversity because we want to have complementarity in terms of what kind of species we have that are capable of responding to increasing disturbances like flooding events or drought events. And so, different species have different traits and capabilities in terms of tolerating flood or tolerating, road salts, for example, or salts associated with, sea level rise. And so a diverse plant community or habitat, both in species number and in structural heterogeneity is critical for supporting wildlife habitat and, a variety of ecosystem services. So, we're fortunate to have a range of freshwater habitats, wetland communities here in Connecticut. So, emergent marshes dominated by sedges or cattails, black spruce bogs that harbor carnivorous plants, peatlands that store a lot of carbon. And so we have calcareous groundwater fed fens up in the northwestern part of the state that support habitat for things like the endangered bog turtle, which is actually a misnomer. It should be called a fen turtle. And our vernal pools, our iconic vernal pools of New England that support, a range of spring breeding amphibians like the spotted salamander and the wood frog. And so, I think it's important, Alda Leopold wisely said back in the 1940s that to keep every cog and wheel is the first precaution of intelligent tinkering. We might not know exactly what every species does, but we don't want to lose all these species. We want to try to preserve it because it will help our resilience and our ability to meet the needs of the future.
Excellent. Thank you very much, Beth. Just a reminder to anybody in the audience to go ahead and put questions in the chat if you do have them, and we'll get to them very briefly here. So just a question for you, Gardner. So USGS oversees the network of gauging stations around the country, and the state water plan actually calls for more data on our water resources in the state and data collection. Maybe if you could just briefly tell us about how those stations are used to predict drought and flood in the state.
Sure. Obviously, we talked a little bit about it, but we're generally looking for, when we develop these or if we're going to use them for predicting drought or for predicting floods, we tend to group them by, we want natural gauges, which is tough to come by in southern New England. Generally, most rivers or streams have some kind of regulations on them, but we typically look for ones that are natural. We might group urban ones together, but we're looking for those that have characteristics. We're doing a low flow study, Liz Ahern and myself, in Mass and Connecticut, and we look outside. The hydrology doesn't stop at the state border, and so we can use gauges that are outside of this area, and we can always use more. And one things that we do as we're doing these equations, we find that one thing that we're really missing is small drainage areas, especially like headwater streams that are important to the whole system, that are kind of, I don't want to say we've ignored them, but they're, at least I think there should be more emphasis on trying to understand that in the whole system. And so I guess that's about all I can say about it. So
that's fine. Great. Thanks, Carter. Yeah, I realize that it's not free to maintain this network, and nobody wants to pay for this stuff. It's not so sexy anymore, really. Like it's a tough thing to fund, but it's really important.
Yeah, and it certainly is one thing that we've really tried to push hard for a long time is just that it would be more support from Congress, for these to help fund them, or at least offset inflation in some ways, because I know it's hard to keep them going, and the longer they go, the more information there is for people. And so anyways, we always are open to more gauges, but the funding thing is always an issue.
Gotcha. Great. Thanks, Gardner. Kip, I'll come back to you, and hopefully my voice doesn't sound bad anymore. I don't know if it was my microphone or what, but hopefully it's not like nails on a chalkboard. So, Kip, you talked a little bit about resiliency and adapting to climate change with soils, and you did hint at this a little bit about the importance of wetland soils in climate change mitigation. But maybe if you could just describe that a little bit more, what you mean, and the role that soils can play in mitigating changing climate here.
Sure. So, again, when we and again, people are using these terms, and I'm glad that Beth clarified resiliency. When we're talking about climate change, people are in some cases interchangeably using mitigation and adaptation and resiliency. When I'm talking about mitigation, I'm specifically using it as relates to carbon and emissions. And so the fact that soils, particularly soils in wetlands, and particularly soils in wetlands in the Northern Hemisphere, are really, really good at storing carbon because it's cool and wet. So there are ways that we can do that. Obviously there are natural processes that are doing that by perennial vegetation and grasses and sedges. They all have their ability, but so keeping the soil covered and keeping the soils healthy. And again, as we talk about soil health, there are soil health practices that we can do to enhance and protect wetland soils as well as upland soils. So we want them to be able to do those functions of capturing carbon from the atmosphere and storing it in the soil, and storing it in vegetation, and storing it in kind of the various kinds of organic matter that are part of the soil system. Some of it is the fresh stuff that is falling on top of the ground. Some of it's partially decayed. Some of it is stored long-term. Beth talked about peat deposits where you can have, basically 15,000 years of partially rotted organic matter that's stored in some of these deep wetland systems. And that's just tremendous. So, and though you need to be able to maintain the hydrology so that they don't start to decay and they don't start to become a source of release of carbon. And that's one of those big issues right now as you get far in the northern hemisphere in what was permafrost areas are starting to melt and releasing carbon, and some of those wetland systems in the tundra areas. That's a concern and a source of emissions rather than something to be able to sequester and store carbon. So there are soil health practices and keeping that hydrology intact in wetlands and keeping native vegetation in particular is really important.
Excellent. Thank you, Kip. So we do have a few questions that came into the chat here. So I'll just pose these and anyone from the panel can feel free to jump in. So from Michael Ferguson, as professionals, how well do you see the Inland Wetland and Watercourse Commissions in Connecticut performing? Any obvious mistakes or misunderstandings you see these commissions making, or any recommendations?
Oh, I'll jump right in there. So one of course, and again, I applaud all of those volunteers that give their time and effort to serve on commissions. And there are some great staff that are out there that are serving commissions. And though, unfortunately, we have commissions that are not well educated and informed that are making decisions, and that unfortunately that we have not spent the money for deep staff and for oversight to make sure that we have commissioners that are well informed and are making good decisions and understand what the impacts are of the decisions. The other thing is, and this is not something that relates to an individual commission, and I think there's opportunities for more staff sharing and things like that to get some professional expertise to help these volunteers, is that there are good things about being parochial and home rule, and there are really bad things about that. And as relates to addressing climate change and natural resource protection and management, parochial system is bad. So you need, I'm a landscape person, and Beth and Gardner are landscape and watershed people, and they don't stop at town boundaries. We need to see more working together across town boundaries to protect natural resources, to protect agricultural landscapes and communities. And that's how we're going to be most successful. So that we need to from our land use planning and what we decide to protect, what we decide to develop, to have more cooperation and cross-town cooperation. I'll stop there. And spend money on staff for deep and for professionals to serve municipalities.
Great. Thank you, Kip. Gardner, Beth, anything else to add to that, or are we good on that one? Good. Okay. Go to another question here from Diane Loricella. Thank you for this terrific series. While I give kudos to all who serve on IWW and conservation commissions, there's varying knowledge concerning IWW and the effects climate change impacts may have on their decision making. What training and resources could help commissioners factor in climate change impacts that are credible? Is there any case law? So I know DEEP, we actually have been involved with that at the Center for Land Use Education and Research. We now host all of the online trainings for DEEP for the various commissions in the state. I am not sure if climate change is a part of the wetlands training now. I haven't gone through that recently. I actually am on my town wetlands commission too, so I will be going through that at some point in the near future. But if anybody knows about that and would like to jump in, please feel free to speak to that from the panel here. Not sure.
Yeah, I'll put my 2 cents in, and I don't know if Darcy's on, if she wants to mention something, but I think that, that I think that would make an excellent kind of module, is to have, with just something like the three, putting together the three presentations that we've put together, maybe, something from a land use planner as well. And maybe somebody, with a legal perspective to put together a presentation as relates to how to think about your decision-making with a climate change perspective. I think that's an excellent suggestion.
It's a great idea, Kip. Thank you. And we're actually looking into some stuff along those lines at CLEAR. Our land use educator is retiring in a couple of weeks, and we're trying to figure out how to do something along the lines of what you're saying. Darcy is on here, and she said that she's happy to discuss concerns regarding after the fact permits. Darcy, I don't know if there's anything you want to jump in on here about the climate change piece in wetlands training.
Sure. Thank you. Can you hear me?
Yep.
Okay. Thanks, Kip, too, for providing that answer. So the DEP does have a municipal inland wetland agency comprehensive training program. It is now an online course. And as just mentioned, it is available, the registration link, through Yukon Clear's webpage, also available on DEP's webpage. The comprehensive training program, it's difficult to hit everybody. There's such a wide range of knowledge and experience out there. So the department had to think long and hard as to what is foundational. What is the information that inland wetland commissioners should know, whether you're a member or a new staff person, or if you want a refresher. So while I agree there's a lot more that can be put into the online course, there was only so much we could do. And climate change is not mentioned, or maybe very barely mentioned. It is something that I was considering adding at a later date, because again, this is an evolving course. Obviously, if the legislature changes the law, then the course has to change. So it is something we are very willing to consider adding in the future, and hopefully maybe working with CLEAR to get some of that information out there. So please see the CLEAR webpage for a link to the course. And there's also an Aquifer Protection Area Training Program course online as well, which is kind of relevant to this. And if you have any questions on roles and responsibilities of inland wetland commissions, please send me an email. I put my email in, I think, the chat. Thank you.
Great. Thank you very much for that info, Darcy. I believe we should be able to make this chat available to when we save this, so that we are recording the presentation, but the chat will be available too, because there's some great information that's been put in here. Alicia just did point out that not so fun fact that only one commission member on a commission is required to go through the basic training for inland wetland commissioners. So I didn't realize that, but hopefully the commissions, I know my town commission is encouraging all of our members to attend. Along this line too, I'll just follow up with one from Eric Thomas here. So Eric's asking, would you see value of towns, perhaps through their IWWA, to estimate or quantify system benefits of inland wetlands and watercourses that are then published in their decadal plan of conservation and development? And how might an IWW or watershed group pursue that as a pilot project? I don't know if anyone has any thoughts on that.
Well, yeah, I would say, right. Beth probably has some thoughts, both Beth and Gardner, on what might be most important to try to capture. I'll let them go, and if there's something else, I'll add.
Go ahead, Beth. Did you have?
No, I don't have anything at the tip of my tongue right now.
Oh,
so
sure.
Yeah.
No problem.
Okay. Again, I would say just, if as part of your inventory, to me, it's not enough just to know where your inland wetlands are in town. You should know something about them. I mean, there are some models and tools for looking at what kinds of ecosystem services that they are providing. And obviously, probably if anything, the ones that people are most familiar that might have different ecosystem functions and values and goods and services is floodplains versus upland wetland areas. That's pretty easy. And that there's maybe, if you have a very active, Conservation Inland Wetland Commission that work together, and that they may have done an inventory that they know, where there are some special habitats that they're trying to protect, that may be, part of their open space acquisition and management plan or something like that. But I would say it's definitely worth having as much information as possible and not waiting till it's threatened by development, or in this case, because of climate change, of understanding what might be the potential impacts. So, and obviously, and if you're in a town that already has a bunch of impervious surface, your wetlands are already compromised. So when you're making decisions, know which wetlands are most compromised by hydrologic modifications. And instead of just automatically friggin' signing off on a permit to do the same damn stupid thing we did last time, let's do something different. Let's pull back the parking lot from the edge of the riparian zone. Let's put in some stormwater basins, people. So let's do things differently this time. So, but if you don't know what's compromised and what's in good shape, you're not doing what we need to do.
Yeah, just to jump in here, I think you said a lot of great things there, Kip. And I think understanding what kind of wetland resources you have in your town or in your watershed are really important, right? Not all wetlands are the same. Just using the National Wetlands Inventory can give you a really good idea of, do you have mostly forested wetlands, or do you have, emergent wetlands, where knowing something about them and engaging with community groups or high schools in the area might be really great, or a good opportunity to learn more about those kinds of habitats. So if you have lots of emergent wetlands, freshwater emergent wetlands that are good for birds, or if you have peatlands that are important for carbon. So knowing more about the wetlands can help inform what you want to prioritize and protect versus maybe it's not as important to the town's priorities.
Great, thanks, Beth. So we're closing in on the hour here. I'm just going to read one more comment here from Lillian Ruiz. So she says that the Council on Soil and Water Conservation would welcome anyone's input as they write a soil health action plan for Connecticut, as wetlands are one of the landscapes covered in the plan. And Lillian has listed her contact information here. She and Denise are working on that. So if you're interested, please contact Lillian about that. I'm going to, I think we'll wrap it up. There are a few more questions in here, but we're out of time, unfortunately. So I appreciate everyone's time, our panelists here. So obviously we can't clap, but I'm sure everyone is clapping in their own individual offices and homes for great panelists in their presentations today. I will just finish up with a plug for our next presentation, which is on June 8th. And there it is. So this will be to celebrate Rivers Month. So Alicia Charmot will be running that show, and we'll be sending out some more information on that as we firm it up. So here's the details: June 8th, 12 to 1, the importance of riparian zones. So thank you to everybody for taking the time with us today. Thank you again to our panelists. We really appreciate all your time and expertise. And go ahead outside and enjoy this nice spring day. Thanks, everybody.
Thank you. Bye.